What's up y'all? My name is Pepe or at Albert J. Black in social media. Today we're gonna touch a very important topic for computer scientists, coders, and programmers. Data structures. Data structures basically do simple tasks that can change drastically the performance of your code. They group and organize your data. The most common data structures that you might have heard of as of today are strings, linked lists, arrays, dictionaries, but you will learn more about them throughout this video, so stay tuned and subscribe to this channel to keep going. But before jumping to data structures, we have to talk about their main components, the primitive data types. You may have heard of some of them, like integers, floats, characters, and so on. The first primitive data type we're gonna go through in this video is numerical data types, wholes, decimals, signed, and unsigned. The main difference between these types is that they can hold different ranges of values. For example, let's say that we have a 16-bit short. That's a signed value. Signed meaning that it can have positive or negative values. The ranges that value of a short 16-bit can cover are from 32,768 negative to 32,768 positive. But if we were to have an unsigned 16-bit short, the ranges for their values would be from 0 to 65,535. Don't forget, this is not a video about primitive data types. So if you want to know more about them, subscribe and like this video and let me know down below. Booleans can either be 0 or 1. That in our language would be false or true. These data types are just as they go. They're easy, they're simple, and there's nothing much to them. The next data type we're going to cover are characters. You can read out this word out loud as caring in a normal language, but for a computer, each thing that's wrapped around a single quote is called a character. It has an ASCII representation, ASCII representation, and for the letter K, that representation is this number 75 for capital K. This helps the computer process the data and facilitate the computations for characters and strings. Data structures use pointers to reference to objects in memory locations. For example, you can have a string. That's a data structure made out of characters. And this string is referencing the object located at location 0 in memory. Their main use is to facilitate connection, grouping, and accessing of your data in an efficient manner. The main data structures you will use when coding are usually strings. As I told you before, this can be also represented as a list of characters. If you get the index 0 of a string, meaning the character that's located at position 0, you would get the letter S. Because they really work kind of arrays or lists, where you can have multiple numbers. For example, in this array we have the number 10, 1, 21, 12, and 30, meaning that this array has a length of 5. But the indexes start at 0. So you can count index 0 equals value 10, and so on. We're gonna talk a little bit more about arrays. Not only because they're really useful, but because they have different implementations. Just keep in mind that each language has their own implementations, and some languages like C may not have resizable arrays like Python does. Multidimensional arrays are like matrices, like your real-life matrices in algebra, where you can have multiple things inside bigger things. For example, in this multidimensional array, we have a bigger and outer array, which has two inner arrays, and each array has their own numbers. Keep in mind that some languages require you that the inner arrays are the same length. But if you want to use multidimensional arrays, that their inner arrays have different lengths, you can go to jagged arrays. They can have different lengths for each inner array. One other important array that we have to go through are resizable arrays or dynamic. The one thing that I love about Python the most is that it's really easy for new programmers. Not only because it has resizable arrays and every kind of array you can imagine. Their definition and their instantiation is very easy. Capital A equals, open square brackets. Then you pour in your data inside. And this data can be as long as you want it to be. You can upgrade it later and add elements at the end or remove elements. As in languages like C, where you can define your array as, for example, your variable name, then your array, then you define the length. This array cannot ever have more than 10 elements because you define the array. You know, the length can never exceed 10, but in Python, each array can always be mutated. Their time complexity is big O of 1 when you want to access an element, just because they have indexes. And for example, if you have an array that goes like this, and you want to access each index to, the big O of n will be big O of 1. Your time complexity will be constant, so you will get immediately, just because they have indexes, the value 12. But if you want to insert elements at the end of an array, what that will do to the array is that every element will be moved to the left. So for example, let's say we want to insert the element 47 to this array. What the code will do is it will generate a new array and start adding elements since the beginning. So time complexity would be big O of n being the number of elements of your array. Now you may think, oh, I just added the number 47, but you did not. You really moved all your elements on the array to the left and then created a new element at a new index. So remember, use arrays when you plan to access a bunch of times at a specific index and inserting a little bit of times. We're going to talk about linked lists. They are really useful. For example, they go like this. They start with a head, usually. If you want to talk about doubly and linked list or double and linked list or double and linked list, they're the same, you can comment down below and say, hey, I want to know more about linked lists, so I can make a video just for you. But for today, I'm just going to tell you about singly linked lists. They just have a head, a node, and each node will point to another node. But before that, each node just contains two pieces of data, the value and a pointer to the next node. How are you going to get to node 3 from node head? How are you going to do it? We do it with pointers. This pointer will point at node 2. This node pointer will point at node 3, and so on. So linked lists are really useful when you want to insert at the beginning of them or at the end. This has a big O complexity of 1, meaning it is constant time, and it doesn't involve taking each node and counting them and doing a bunch of calculations for you to perform these actions, insertions at the beginning or the end. But if you want to delete a node or access their values, time complexity kicks in, and the big O becomes big O of n being the number of nodes you have in your program, in your data structure. In this case, would be big O of 4. We're gonna do a little sidebar here. I know that big O complexity can be confusing, so I'm gonna try to explain it my best in 1 minute. As we know, as I mentioned, big O just means the time that it takes a code to run. For example, you know that big O of 1 is constant, meaning no matter how much data you have 10 samples or 1 million, the code will always run in big O of 1 in constant time. The next best thing would be big O of lg of n. lg is just the log base 2 of n. But in coding, we just simplify. Get rid of the O, get rid of the 2, and say lg or log of n. Meaning that if you have 10 samples, your code will run in lg log base 2 of n. In this case, n would be 10. So the time for your code to run would be lg of 10. What does linear mean? Just a simple line, which means that if you have 10 samples, what will it take for your code to run? Big O of 10. If you have 1 million samples, it would be big O of 1 million. That's linear time. Next best thing after linear, you don't want to go there. You never want to go there. Would be n, your samples, times the log of n. It's even worse than linear, but the worst of the worst would be exponential time. N squared, n cubed, n sixth. It would take a lot of time for your code to run. If you want to know more about big O and time complexity in detail, let me know down below. Comment, hey, I want that big O to be less fat.